Hello guys, welcome to this lesson. In this lesson, we are going to discuss the radius of an atom and its ion. The radius of an atom and its ion, that is ionic radius variation. We know basically that when an atom loses or gains an electron, it forms an ion. Is that okay? So when there's loss or gain of electron, an ion is formed. We also know that we have two forms of this ion. We have the cation and then the anion. That is, a cation is formed when an atom loses an electron, and an anion is formed when an atom gains an electron. How do we vary in terms of the radius between this atom that is losing an electron to form its cation? What is the variation in terms of the radius, and also the variation in terms of the atom if it gains an additional electron to become an anion? Is that okay? So we are going to begin the lesson with the variation between a cation and then its neutral atom. So we are going to discuss a cation variation, a cation and its neutral atom. So for example, let's take lithium. Lithium is atomic number 3. So if lithium loses one electron, it changes to the lithium ion. Is that okay? So this is a lithium neutral atom and this is a lithium ion. Is that okay? So we discussed the variation with the radius of an atom on a periodic table. We said generally the radius decreases from the left to the right across a period, and the radius again increases from the top to the bottom of a group. Is that okay? But once we're talking about a neutral atom and then its ion, we are going to discuss the proton-electron ratio here to explain the radius. Is that okay? So once we take the neutral atom in lithium here, we have 3 protons. Is that okay? And electron, we have 3 electrons in the lithium neutral atom. But once we get to the lithium ion here, we have 3 protons, but we have 2 electrons because there's a loss of electron in the ion here. Is that okay? So once we compare the proton and electron with the neutral atom and also with the anion here, with the cation here, we could see that for the lithium ion, it has more protons against its electron. Is that okay? The lithium cation has more protons against its electron. And the moment the protons is more than the electron, it means that there is more nuclear attraction, but there is small electrons to cause repulsion, which brings about reduction in attraction. That is coming from the proton. Is that okay? So for cations, since they have more protons against the electrons, it means that there is a high nuclear attraction in the cations against the electrons that repel each other to bring about reduction in attraction. So therefore, the size of the cation will be smaller once it is being compared to its neutral atom. And the argument is simply the excess protons against the electrons. Whenever protons exceeds the electrons, that is going to cause repulsion and bring about a reduction in attraction. There is going to be a decrease in the radius of that species. Is that okay? So for a neutral atom and its cation, the cation has excess protons, and excess protons increases its nuclear attraction, thereby decreasing the size of that species. So cations have smaller radius compared to the neutral atom. Is that okay? Alright. So since we are discussing ions, let's also consider anion and then its neutral atom. So let's consider fluorine. Fluorine is atomic number 9. So this is a neutral fluorine atom. When fluorine gains an additional electron, in order to be stable, it changes from the fluorine atom into the fluorine ion. And that is the fluorine anion. Is that okay? With the fluorine atom here, so this is the anion. With the fluorine atom here, we have 9 protons and then we have 9 electrons. But with the fluorine anion here, we have again 9 protons, but the number of electrons will increase because there is an additional electron, which is indicated here, the negative one. Is that okay? So we have 10 electrons against 9 protons. And then for the neutral atom, 9 protons against 9 electrons. So once we consider the ion here, we could see that the electrons exceeds the protons. It simply means that the electrostatic repulsion between the electrons will be much greater to bring about a reduction in blockage in attraction caused by the protons in the fluorine anion. And anytime the electrostatic repulsion increases or it is greater than the nuclear attraction caused by the protons in the nucleus, it simply means that the radius of that species is going to increase, or the distance between the valence electrons and the protons becomes very, very wide. Is that okay? So for anions, since they have excess electrons against the protons causing a nuclear attraction, there is an increase in reduction in attraction and thereby increasing the size of the anion compared to its neutral atom. So for anions, they have excess electrons against protons. So excess electrons in the anion, but once we are considering the cation, they have excess protons. So for the cation, they have excess protons against the electrons, but for anion, they have excess electrons against the proton. And whenever the proton is in excess against the electron, nuclear attraction will increase. And whenever nuclear attraction is increasing, it means that the radius of that species becomes very small. And also, whenever there is excess electrons against the proton attraction, it simply means that there's going to be more blockages caused by electrostatic repulsion of the excess electron, thereby reducing the nuclear attraction caused by the proton. And once that happens, there's going to be a reduction in attraction caused by the proton, thereby increasing the radius of the species. Is that okay? So for cations, they have smaller sizes due to excess protons, which increases their nuclear attraction. But for anions, they have excess electrons against the protons, which brings about a reduction in nuclear attraction. So comparing a cation, a neutral atom, and an anion in terms of their radius, the smallest one will be the cation, followed by the neutral atom, and then the anion. Is that okay? That is a basic ideology on ionic radius. Okay,